Welcome to my video lecture on electric tractive motors. In my previous lectures, I have already discussed about the other motors of electric tractive system and what are the factors basically we need to think before choosing the electric tractive motors. In my previous lectures, I have already told you about the DC series motor, which is very important for tractive system. In this lecture, we will mainly highlight on the AC motors. And this topic is included in the paper of Utilization of Electrical Power, paper code EE702. Myself, Kumu Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra Degree Engineering College. In this lecture, we will mainly deal with the AC tractive motors. And in AC tractive motors, there are mainly three types of motors that generally used for traction system in case of AC. That is AC series motor and induction motors. In induction motors, it can be single phase induction motor or three phase induction motor, and also linear induction motors are used for the electrical tractive motors. And basically, it has been seen that many parameters we have to keep in mind while we will choose this kind of motor. In DC series motor, all the parameters which are matching very efficiently, that I have already told in my last lecture, and so what are the reasons behind picking DC series motor that I will discuss in my last lecture. In this lecture, I will show you about AC series motors and induction motors. So I will proceed with my lecture, that is AC series motor. Many single phase AC motors have been developed for traction purposes, but only compensated series type commutator motor is found to be best suited for the traction. There are various motors are there, but the factors we need to choose while taking the motor for traction system, those are not matched with the AC motors. But among the all other AC motors, it has been seen that the compensated motor compensated series type commutator motor is found as best suited motor for AC traction system. Single phase induction motor have been abandoned as they are not capable of delivering high starting torque. So single phase induction motor are not taken for traction motors as it is not capable of giving high starting torque. The construction of AC series motor are very similar to DC series motor, except that some modifications such as pole magnetic circuit laminations, series field with few turns as possible, large number of armature conductors, use of high resistance, carbon brushes, numerous poles with lesser flux per pole, very short air gap, etc. are modified compared to DC series motor, are incorporated so to obtain the better performance. Compensating windings are provided to neutralize the armature reaction, and commutating or interpoles are provided for better performance in terms of higher efficiency and a greater output from the given size of armature core. So this is the circuit for AC series motor. We can see there is armature, main field winding is there, compensating winding, interpole winding, non-inductive shunt resistor is connected, and here single phase AC supply is given. The average value of torque on the motor shaft in case of AC series motor is 1 by 2 root 2 pi Z P by A phi max I cos theta, where I is the effective value of current, phi max is the peak value of flux per pole, and theta is the phase angle between the phases of phi and I. So this is the torque for AC series motor. And now I will highlight about three-phase induction motor. Basically, three-phase induction motor is very efficient motor in case of different industrial applications. And three-phase induction motors are very cheap robust in construction, it requires less maintenance. And that is the main purpose that three-phase induction motor is very popular. And here, three-phase induction motor has lots of advantages which we have already highlighted, that is robust in construction, trouble-free operation, less maintenance, high voltage operation, consequently requiring reduced amount of current, and automatic regeneration is possible in case of three-phase induction motor. But due to their flat torque speed characteristics and constant speed operation, developing low starting torque, drawing high starting current, complicated speed control system, and complicated overhead feeding system, they are not suitable for electric traction work. It is also impossible to employ three-phase induction motor for multiple unit system in which two or more locomotives are used for propelling of a heavy train. In traction system employing three-phase induction motors, it becomes necessary to couple all the driving axles through a connecting rod so that there is no possibility of difference in speed. With the development of thyristors inverter circuits, it has now been possible to invert the supply and obtain variable frequency supply, which could be used for three-phase induction motor with a very smooth speed control. Okay, so this is very important that three-phase induction motor can be smoothly speed controlled by using three thyristor-based inverter circuits. Induction motors are good power factor and good efficiency at speed near to synchronous speed of the motor. Now in conventional method of speed control, change of sleep method is normally used, but in this method at low speed of motor or at high value of sleep rotor losses will be more, so good efficiency cannot be obtained. To get good efficiency and good power factor, synchronous speed of the motor itself can be brought to a lower speed near to desired actual value of the motor. This can be done by supplying the motor with help of variable frequency supply. So, after invention of the variable frequency drive, like using cycloconverter drives or fixed-phase thyristor-based drives, then three-phase induction motor can be smoothly controlled by variation of frequency as well as voltage. So, when this mechanism is implemented, then we can use the three-phase induction motor partly for real-time traction systems after invention of this frequency control drives of three-phase induction motor. Starting current of motor is also decreases when the motor is started with low frequency. When three-phase induction motor is used, distribution system consists of two overhead lines and track rail for third phase to feed power to locomotive. This gives a complicated overhead structure. Another problem is typical brief complicated overhead structure because of three-phase induction motor means distribution system consists of two overhead lines and track of the rail for third phase to feed the power to locomotive. So that is another difficulty for using of three-phase induction motor in case of traction. This drawback is removed while employing the Candu systems. In this system, the single-phase high-voltage supply is given to locomotive with help of single overhead wire. In locomotive, the single-phase supply is converted to three-phase supply with help of phase converter and feed to the motor. Now, Candu system is in use of Hungary and some section of Italian states Belgium. So, nowadays, by implementing this Candu system using single phase supply to three phase supply converting, some in induction motors, three-phase induction motors are partly used for the railway traction system in Hungary and Italian state of railways. Now we will go to linear induction motor part. It is a special type induction motor which gives linear motion instead of rotational motion, as the case of conventional induction motor. That means we know that conventional induction motor gives you the rotational output, but in case of linear induction motor, it will give you the linear motion as output. It operates on the same principle as of conventional induction motor operates. Whenever there occurs a relative motion between the field and the short-circuited conductors, currents are induced in them, which results in the electromagnetic forces, and under the influence of those forces, according to Lenz's law, the conductors try to move in such a way as it eliminates the induced current. In case of conventional induction motor, the movement of field is rotatory about an axis, so the movement of the conductor is also rotatory. But in case of linear induction motors, the movement of the field is rectilinear, and so the movement of the conductor. That means we have to remember that for linear induction motor, the movement of the field is rectilinear and it is movement of the conductor is also linear. Okay. Now we will highlight about some features of linear induction motor. The speed of three-phase induction motor is ns minus nr by ns, that means synchronous speed minus rotor speed divided by synchronous speed is sleep of three-phase induction motor. But in case of linear induction motor, we will highlight it as Vs minus V divided by Vs, where V is the actual speed of the rotor plate. Now, thrust or force or tractive effort in case of linear induction motor, that is F equals to P by Vs, where P2 is the actual power supplied to the rotor, and active power flow is similar to that in case of conventional induction motor. That is, copper loss in rotor equals to S into P2. And mechanical power developed for three-phase induction motor, it is basically P mechanical equals to 1 minus S into P2. The tractive effort will be a function of slip, that is Vs minus P. The thrust or tractive effort speed characteristics of linear induction motor, as we have shown it in the figure, that is the thrust F in newtons with speed variation. This is the speed variation with the tractive effort, that is the graphical nature. The tractive effort F can be controlled by varying both frequency and voltage simultaneously, so that the induction density remains constant. That means here we will also take in the help of power electronics based drive system to vary the voltage as well as frequency to change the speed of the motor in case of linear induction motor also. Now we will see some advantage and disadvantage of linear induction motor. The advantage part of linear induction motors are basically it gives you low initial cost. Definitely it will give you low initial cost. Second, it requires low maintenance and cost because of absence of rotational parts, because it is linear in motion, so definitely it does not require rotational parts. Third part, it is simplicity, and fourth, no limitation of tractive efforts due to adhesion between the wheel and the rail. Now, fifth part is no limitation of maximum speed due to centrifugal forces. Sixth point, no overheating of rotor because the motor moves continuously over full rotor plate, leaving behind heated rotor portion, and better power to weight ratio. These are all 7 points are there which are basically the advantages of linear induction motor. And for this reason, in Japan, linear induction motors are used for magnetic levigated train. Magnetic navigation system uses linear induction motor. And there are some disadvantages are also there for linear induction motor, and that is it has poor utilization of motor due to transverse edge effect and end effect. Secondly, it has large air gap and non-magnetic reaction rate, and it needs more magnetizing current, resulting in poor efficiency and low power factor. Thirdly, it needs very high capital cost of reaction rail fixed along the central line of the track. And fourthly, complications and high cost involved in providing three-phase collector system along the track. And fifthly, difficulties encountered in maintaining the adequate clearance at points and crossings. Those are the main disadvantages of linear induction motor. So I have discussed just briefly about the AC series motor and induction motors, why two-phase induction motors are not very suitable for tracking system that I have highlighted, and why single-phase induction motors are generally not used for railway traction system. That point I have already highlighted to you. And some newest invention, that is linear induction motors, that is very newest technology which is involved in case of traction system. That part I have already discussed in this lecture. So now I have tell you about the applications of linear induction motors, why these linear induction motors are generally used. Linear induction motors can be used in conveyors, traveling trains, howlers, electromagnetic pumps, high-speed rail traction, etc. Such motors may be employed in application in which the field system moves and the conducting plates remain stationary, such as traveling train motors. It is also used for traveling train motors. These motors can be used in application where the field system remains stationary and conducting plate moves, such as automatic sliding doors in electric trains, that like our metro railway, it has automatic sliding doors where after just moving of passengers from platform to train, that automatically doors are sliding and they have been closed. So there we can use linear induction motors. Also for metallic belt conveyors can be used. It is also used in trolley cars for internal transport in workshop, as booster accelerator for moving heavy trains from west or up the inclination, or on cars or propulsion units, marshalling yards in case of shunting locomotives. Linear induction motor has superiority over conventional rotary motor for speed over 200 km. I have already said that linear induction motors are used for magnetic levitation system, and those trains we know that it is called as bullet trains. That means it has huge speed. So here that is the reason it can create 200 km per hour speed by using linear induction motor. So linear induction motors are used for those bullet trains, magnetic levitation system. Linear induction motor provides excellent source of motive power for magnetically suspended train where conventional rotary motor fails. Because of latter depends on torque conversion to linear tractive force upon adhesive weight on driving wheels. The use of linear induction motor is limited only to applications till now, owing to design difficulties and economic considerations. But still, we have to remember that for making such kind of system, it involves huge amount of money. So definitely, for moving all these Indian railway traction system to using linear induction motors, that will cost a huge amount. So definitely, we will always choose those motors which are cheap and robust in nature, and it will give us better output with lesser amount of cost. So, thinking about the cost factor, we are always choosing the DC series motor in place of traction system, and so the linear induction motors are generally not used for Indian railways. So, after this is for today's lecture. Thank you all. Thank you for listening my lecture.